Okay, here we are, STAWA set 18, looking at question 2, which is asking us which of the following reactions determine whether any elements have undergone a change in oxidation number, and, and note whether they have been oxidized or reduced. Okay, I'll start with the first one very easily to show you how it's done. So, starting with number A, we notice that we have got magnesium and we have oxygen, and that there are no other atoms in the substance there. So, in other words, magnesium is elemental, and oxygen is also in its elemental form. Now, we know from our rules that elements in their elemental form are given an oxidation number of 0. So, magnesium starts at 0, oxygen at 0, and then we form this substance over here, magnesium oxide. Ignore the 2 at the front. That just tells us how many of those we have. But magnesium oxide is the thing that we need to focus on. We know from our rules that oxygen forms -2 unless it's a peroxide, which isn't the case here, or unless it's elemental, which is also not the case here. So we've got -2 on this side. The overall charge of the overall oxidation numbers must add up to 0 on this because it's a neutral substance, it's not an ion. So if this one is -2, then this one over here has to be equal to +2. When you go from 0 to +2, you give up 2 electrons. So in other words, the giving up electrons is called oxidation. Magnesium is oxidized. On the other hand, when you go from 0 to -2, you gain 2 electrons, two negative charges, -2. So in this case, the oxygen is reduced. And that's how to tackle those ones. So all those are pretty fine and dandy until you get down to 2E, where it starts to get a little bit more interesting, but it's essentially the same approach. Note that we've got this permanganate ion, MnO4-. So what have we got over here in this situation? We've got manganese ion, permanganate ion. It reacts with hydrogen sulfide in an acidic environment to make manganese 2+, elemental sulfur, and water. So let's have a look at this manganese ion. Oxygen is going to be -2. We've got 4 of them in these things, so we've got -8. But -8 has 1 extra charge on it. Why don't we, in that case, if -8 is 1 negative, let's add a charge to both of those so that this is 0. -8 becomes -7. So this manganese here has to counterbalance 7 negative charges from the oxygens. So manganese must be +7. Sulfur in this case is -2 because we know that these H's are +1 each, and notice that we've got 2 of them. 2 times +1 is equal to +2. So the sulfur which counteracts that has got to be -2 for the whole thing to add up to its overall oxidation of 0. So +7 and -2 goes to manganese, which is +2. We know that because that's the charge on the ion. And elemental sulfur, which is 0. When you go from -2 to 0, what happens is that you lose your electrons. Oxidation is lost. So the sulfur is oxidized in this form. Manganese, by the other hand, becomes more negative. +2 is more negative than +7. You've added 5 electrons to it. So manganese is reduced and sulfur is oxidized. That's all that there is to it. Okay, now focusing on the dichromate, our old friend dichromate. You'll remember from the equilibrium studies, that experiment that we did. So this orange dichromate reacts with iron 2+ in an acidic environment to form chromium 3 and iron 3 and 7 waters. Now, it's always good to be suspicious when you see any of these transitional metals, chromium, iron, together. They're quite frequently involved in redox reactions. So what happens in this situation? We've got 2 chromiums, okay, and we've got 7 oxygens. So there are 14. There's minus 14 worth of charge on that. But that gives us 2 extra charge. So in actual fact, if you subtract that 2 from both of them, okay, you will end up with minus 12 from the oxygen, okay, and if this thing were neutral. Okay, now 2 lots of something is equal to minus 12. Cr must be equal to plus 6. If you wanted to write it out as a little equation, you could say 2 times Cr plus minus 14 equals minus 2. Notice that the oxidation number adds up to the charge of that thing, and then what we do in that situation, well, let's make it 0. Let's add 2 to that. That makes it 0. Let's add 2 to that. That's minus 12, and then it becomes easy to solve algebraically. 2 times something, when added to 12, equals 0. That something must be plus 6. Okay, that's the hard one done here. Taking a look at the iron, we go iron 2 plus to iron 3 plus. It has lost another electron. So oxidation is lost, the iron is oxidized, and the chromium is reduced. Okay, and that's pretty straightforward. And the last one of these, which is really a bit fun, is to look at this funny thing here, this ammonium nitrate. Great for mixing with diesel and blowing up rabbit holes in the old days. Now banned and very hard to get because of its potential use and interest to terrorists. You'll notice that Bunnings no longer sells this. When I was a kid, almost all of the fertiliser was in this form. Since 9/11/2001, what's actually happened is that this has been withdrawn from the market because it's been so easy and it was available in such bulk for making bombs with. Anyway, that's the chemistry to it. Let's go have a look at the oxidation numbers. If you look at this thing, you can see it's an ionic substance. Overall, it adds up to 0, but your ions involved are NH4 plus and NO3 minus. Okay, so what happens in this sort of thing? We know that in ammonia, we've got ammonium ion is a plus. Let's add an electron to it, NH3. If it were NH3, the iron would be in the the nitrogen would be in the +3 state. If we look at this one, we've got minus 6 due to the electrons, but we've got a negative charge there. So overall there's minus 5, if you like. So N is going to have to be equal to 5 on this, and N is going to be minus 3 on this. So what actually happens in this molecule is this oxygen here goes from minus 3 to 0, because remember it forms nitrogen, which got an oxidation number of 0. Minus 3 to 0 is an oxidation, isn't it? But plus 5 to 0 is a reduction, isn't it? So this nitrogen here is being oxidized, and this nitrogen here is being reduced. And together they end up with the nitrogen in the 0. So one nitrogen is oxidized and one nitrogen is reduced, all within the same molecule. And that's how to do those ones. Hope you enjoyed.